Hey, what's up, guys? So we're gonna just continue with our model, and let's interpret what this means, the results of our model. So again, we looked at volatility as a measure of value, and specifically we had an output of negative 0.20, for that was what our model predicted the earnings yield should be, versus the market's earnings yield of negative 0.0067, which is basically zero. And so how can we interpret this? So essentially our model is saying that the value of Tesla, the earnings yield for Tesla should be lower than what the market believes the earnings yield should be. So we can interpret this as the market believes Tesla is undervalued. It should have a higher earnings yield given its volatility, but versus our model. So that's an interesting inference that we're getting from this. So let's take a look at technology companies and use the same model, use technologies as to build a basis for a model using volatility as the variable, and see, does that change our results of what the earnings yield should be. So to do that, we're going to, first we need to just take our data frame, our original data frame, and we're going to, and remember the original data frame was above here, looked like this up here. And so all we have to do is, instead of taking out, remember we sorted the industries, we found the industries, we're gonna look at technology, and I believe it should be internet information providers. That's the specific industry we're gonna look at. And so I'll print this out. So again, we use the same formula here, or same process here, but instead of auto manufacturers, we're going to look at internet information providers. So I'm just going to change this to internet information providers, and we're just going to call this tech DF. So let's run that. DF is not find. That's because I need to run through this again. So I'm just going to run all through this. And let's see if that works. Yep, it did. So now let's see what tech data frame looks like. So here we go. You can see we have Commute Technologies, Yelp, Baidu, Zillow. I believe Google's in here if you look through it. So now we're going to do the same idea here. So let's go back up here, and remember we hypothesized these are the variables that we're interested in: sales growth, gross margin. We're going to go through the same process here and find these relationships. So I'm just going to copy this here, and instead of auto DF, we're going to call this tech DF data frame. So let's run that. Now let's see, look at what it is. So there we go. These are the variables that we're interested in. And so we're going to go through the same process. We're going to just import stats models .api as SM. And we need to, from Patsy, import D matrices. Let's copy all that. Looks like I didn't really need NumPy, but we'll just NumPy as NP. Let's actually look at the relationships. So remember, we want to do some scatter plots. So to do that, we're just going to take plt.scatterplot, and I believe we already imported plt. So I'm just going to take these guys here, and we're going to say this is going to be our tech DF. And let's take a look at sales growth. Run that. Ooh, don't like that at all. Let's take a look at, what else do we have in here? We had gross margin. Yeah, all of these don't look too good, do they? Gross margin and earnings yield. Let's look at operating margin. This is a better this is a better relationship here. I kind of like that. Let's look at profit margin. Again, this is not really a strong relationship here. And then finally, let's look at return on equity. Return on equity. Very hard to see a relationship there. And let's look at earnings per share growth. Definitely not a relationship there. So remember, earnings yield is on our y-axis. And then notice how the earnings yield, a lot of these are very low and negative. Okay, so that's some of the variables that really. Oh, finally, we also want to look at volatility. So let's look at volatility here. So vol, again, not a great relationship here. These are not really strong variables to be using. There might be outliers here, so we might have to remove this. Look, notice this. This is again volatility right here, right? Where earnings yield is -6, which is very large. We might have to clean up some of this data. So let's do that. So I specifically want to look at this really large outlier here. I don't want to use this data if it's messing things up. So we'll probably remove that. So let's take a look at that. So again, our tech DF. Let's look at what we got here. And let's look at earnings yield column greater than 5. And then to look at that column, we have to just specify tech DF, and then we put that conditional in there. And sorry, less than -5. That's what we know. So JMU, this is the one that's this really odd one here. So we're gonna remove this. Notice we can't even use a lot of these other variables here. So we're gonna drop U. And to do that, we're just gonna say, so let's take our tech data frame, and we want to look at the ticker column. So if it equals vol or equals JMU, let's take a look at that. So we want to drop that. So it does not equal JMU. So there we go. So we've dropped it. JMU's out of here. So now let's create, we'll call this tech data frame 2. So let's look at tech data frame 2, and we're gonna use plt.scatter again, and that's tech data frame 2. Let's run that. So here we go. We can see a better relationship here. Again, we have another outliers. So you can see how we can manipulate the data, and that's not always the best thing to do, but in some cases it may be. So it depends. There's different reasons for outliers. It could be maybe there was a data entry issue. Maybe it's not relevant. But you have to remember that the more you massage this data, the more you're data mining, and you're gonna make many assumptions. In this case, I'm gonna remove JMU since it's a smaller company. We don't have a lot of information about it, so I'm removing it from this set. Let's take a look at this one up here, 0.6. I'm curious about this. You'll notice we're having a lot of negative earnings yields here. This is very interesting, actually. So I want to take a look at our tech data frame, and let's just look at the ticker column because I'm curious what's in here now. So, so let's just say for underscore in that. Print underscore. So who's in here? So we do have Google. We do have a lot of interesting companies in here. Grub, JMU. We have both Googles in here. See, that's messing things up too. JMU, Mark, Fun, TCX, Yelp. You know what? These do have negative earnings yields, don't they? Okay, so let's I'm curious what this is too now. So let's look at, let's take this formula here and say anything greater than 0. We have a lot of positive earnings yields here, so we do have a lot here, it seems. Who's this one greater than 0.6? 0.5. JFIN. So what is JFIN? Curious who these companies are. Let's go look up JFIN, huh? Let's see who JFIN is. So the Chinese company, internet finance. Not a lot of information on these guys. China-based company mainly engages in the provision of online individual financial services. The company's loan facilitation services mainly matches investors to the company's marketplace. That's actually really interesting. Yeah, very interesting. So I'm going to remove that for now. Just so that we can build this model out better. So let's just take, again, we're going to do the same thing here. I'm going to call this DF2, and we're going to remove JFIN now. And remember, I want to work off data frame 2, and we'll just call this DF3 just so we can see the process that we're doing here. It's DF2. So remember, we have to add DF2 for both of these. So we're going to remove JFIN. So now we have tech. So let's see if we can, so you can see what we're doing here. We're really massaging this data, which can be a good thing and a bad thing. So please keep that in mind. So we have a better model here. So let's try to build this out. So I'm gonna say, again, we're gonna import. So we already imported our stats models, correct? I think we did here. Yes, so we're gonna use D matrices again. So let's just, y and x equal to D matrices. And we're interested in earnings yield, and that's, and vol. And the data that we're gonna be inputting in here is the tech data frame 3, remember that. And the return type, this is going to be equal to data frame. Let's run that. So we have our y variables, we have our x variables, intercept, so we can build this model out now. And let's do that. So model is equal to stats models dot ordinary least squares, and put our y variables and x variables, and results will be equal to our model dot fit results dot summary. Let's see how this looks. Not a very strong R squared, but the t statistics are significant. We massage the data. Let's see. Let's look at our params. Results dot params, and again we can use the same formula here like we did with our auto data frame. Where's that? Here we go. So we'll use the same formula. Again, this will be the new results, negative 0.228. And so again, it's very close. It's predicting a very close earnings yield as our auto data frame, but actually it's predicting that it should be even lower. All right then. So these are some interesting findings. I think what I want to do now is probably build out the model with some additional variables, see if we can find something else here that looks a little more interesting. And again, how can we interpret this? And since technology industry is saying that it's predicting an even lower earnings yield versus the market. How can we interpret that? Basically, we can interpret that as technology, using the technology model as our basis to value Tesla. The market is significantly undervaluing it. It's giving its even higher earnings yield. So in a sense, versus what we predict with our technology model. So in a sense, you could think of it as using technology to build our model, using technology companies to value our security, really is saying that Tesla is significantly undervalued. So we'll continue with this process and add some more variables and build out this model and really try to understand, what are the drivers of Tesla really. So if you like this video, please subscribe. Until next time, guys. Thank you.